Now, question 9, foundation paper, mock. We've got sources of background radiation. Some are man-made, some are natural, and we've got a mixture here. Cosmic rays are a natural source of background radiation. Cosmic ray particles are hitting from all directions on the Earth's atmosphere from outer space, and they are a natural source. Radon gas, it comes from radon rock underneath, embedded into the ground, and in certain areas around the world, you have this radiation seeping through the ground, and that is also a natural source. We have created as man X-rays at the hospitals, nuclear power stations we've created and built, and nuclear weapons again we have built. So all of this is man-made, and these two are natural. A teacher is using a GM tube and count meter can measure the background radiation. So this is the detector, and this tells you how much radiation has been detected. Now, the amount of radiation detected after 1 minute in the air was 16 counts, 21 counts, and 18 counts. So, a slight difference in each count. And the reason for that is because when we get radiation, it is a random process. The decay process is random. So, we're not each nuclei which ends up releasing radiation relative to the sample, it all happens spontaneously, so therefore it's a random process. Part C. Lead is used to absorb the radiation inside the box. So the lead lining absorbs emitted radiation, and it's good for absorbing all types of radiation, all alpha, beta, and gamma. Part D. Teacher uses the arrangement of the GM tube, which detects radiation, and the counter, which tells you how much radiation is detected, and they put a radioactive source next to the GM tube. And what we see is a reading being taken of 159, but we also know that that includes some radiation from the air as well, some natural background radiation. So, what we need to do to find the correct reading for what the radiation the source gave out is remove the background radiation. So, subtract the background radiation from 159 to get the actual radiation coming out of the radioactive source. Okay, so we had this radioactive source, and a teacher passed our source through an electric field, and we saw that the source deviated in its path. Okay, so we saw the source deviated in its path and towards the positive plate. Now, if a particle is moving towards a positive plate, it means that it must be negative. Okay, so what radiation do we know which is negative? It is beta radiation, which is an electron, and electrons are negative, so they are going to be attracted to the positive plate. Alpha is positive, so it will bend the opposite way, and we don't see that. Gamma doesn't have any charge, so it will go straight through. And neutrons not have any charge, and they'll go straight through as well. And the reason for beta is because beta has a negative charge, which makes it attract the positive plate, and this forces the path of the electron to deviate towards the plate.